un museau sur ta main, un souffle de chaleur, tout va mieux. Soudain, tu respires en couleur. Le chat blotti contre toi, il ronronne, il te croit, reine du monde, rien que pour lui. Quand tu doutes, il s'endort aussi. Le chat blotti contre toi, garde tes secrets dans ses doigts, dans ses griffes, rentrées dans sa nuit. Il ronronne, il reste ici.
Yeah, there we go. We're live with Ben. Oh, you can change your name. Right now you're Anon. You can change it up there in the right here. Yeah, okay. Yeah. Just like click a little pencil guy. Yeah, and then you can name yourself, so you don't have to be Anon. Welcome. This is a SlopComputer, a little bit impromptu SlopComputer. Thanks for coming. Thanks for being here. Let's get into it. So you work at Aztec, is that right?
It's not right.
That's not right. You worked at Aztec? Never. No Aztec.
Never actually.
Okay.
Never.
It was just Raul that had connected us, so I thought maybe it was Aztec.
No,
I'm sorry.
I work with the Ethereum Foundation, so I know Raul from the Ethereum Foundation.
Oh, you're at EF. So you we work
at
at the same place.
I work with them. Building Verity, so we have a grant. So I say
okay.
With the Ethereum Foundation, maybe not at, or maybe I made a mistake. But yeah, sorry about it.
No, all good, man. Okay, so I think the key that we're talking about here is just like your what I call slopperation. You are probably a slopperator, right? There's this new term of this person who is like this, I don't know, wrangler of many different Claude and Codex windows. Would you consider yourself a slopperator?
Very much, very much.
Hell yeah.
For a long time, actually. For the anecdote, we've been using Cursor like 2 months after the launch of the IDE. So yeah, for a long time.
And you're building something called Verity, is that right? And the fact that you vibe coded, Raul said you single-handedly vibe coded an entire language. That's what we should talk about today. Yeah, that's cool.
So I'll not take all the credit because a big part of it is also my co-founder, and you can check on his GitHub. But like we're working on the vision and the company together, so I can describe everything about it.
Let's go. We're here. I'm ready. I'm ready for it. Let me even pull up a share. We can share your GitHub or something. What is the good thing to share to talk about this? Verity.
So maybe I can talk a bit about like Verity and why we build Verity and how advanced it is right now. So basically, Verity is a language that permits you to write smart contracts. So that's my GitHub, but I think the important one is like the repo of Verity here. And it's a language that permits you to write smart contracts. And the interesting thing is that, well, we weren't 1 year ago, we weren't in need of another smart contract language. Solidity works well. The II knows well Solidity. We didn't really think we needed a new smart contract language in any way. But something happened in November of 2025. We think at Verity that in November 2025, basically AGI came to us under the form of Opus 4.5. And basically these models were now able to like be better than any software engineer on earth, I would say. And with the arrival of Opus 4.5, we understood with my co-founder Thomas, that is the main contributor of the language, we understood that basically the future of software is writing a lot of code, but not you, the agent, of course. We understood that before, but here we understood that, okay, formal verification is probably the future for securing software. And formal verification is something that was very, very, very expensive before LLMs came out, because you had to pay PhDs, basically math PhDs, to write proofs that your code is correct. And Verity, basically, is a smart contract language that permits you to do formal verification on Ethereum. And the good thing is that it's built directly from the ground up with AI in mind in order to formally verify your code. So I can go deeper on that, but the idea is that in order to formally verify smart contracts, you have to do 3 main things. And all of the techniques you will see out there, we have these 3 main things in some way. The first thing will be modelization. You have to like take your smart contracts and express it in a mathematical way, because you have to express the problem. And then you have like to write, okay, what are the rules I want my smart contracts to follow? So most of the rules are around my user are not losing money, basically. And then you're gonna prove that like in all possibilities when you run this code, well, this rule is not violated. You don't have one counterexample of this rule. And this is the main big change that we saw in November 2025, which was, before math PhDs needed to write the proofs themselves and think a lot. Now we have math PhDs in data center for 50 cents an hour. So it's now becoming like abundance of formal verification. And we can see it now playing because last week, actually, GPT 5.6 or 5.7 or the latest version of GPT was able to, for $2,000 of inference, was able to solve mathematical problems that weren't solved before. So these LLMs are very, very good at math, and we can say like probably way better than any human already.
Okay. And so TLDR, written an AI-first language to do formal verification on smart contracts. Just to start with like the headline. Is that what?
It is correct.
Is that right?
It is correct.
Okay. What makes it AI first? Other than being built with AI, what makes it like AI ready? The language itself, or
So
why
it is
create a
Lean.
new language for AI? Sorry, go ahead.
I said there is like these three ways. So modelization, make the rules, and then the proof. We were able to do modelization before. Of course, it helps with AI because AI is writing some code for you. But we were able to do it before. Specs also, so writing the rules, we were able to do it before. What AI changed in the whole process is the third step, mainly, I would say. Because the third step enables you to, maybe, for example, a code of 1,000 lines. To prove it, it will be like 100,000 lines or 10,000 lines. Way more complicated and a lot of more lines. But now it's not a problem because AI can write these lines and the feedback loop is, oh, I write, I verify with the compiler, I say, lean build, it does build or it doesn't build. If it doesn't build, I go again and again and again. And that's how OpenAI is able to verify all these theorems and make all these incredible mathematical discoveries in the last week, is because the feedback loop is very, very easy. And it's binary, it's Boolean. It's like yes or no. And this is why, basically, we built it Verity, because we are now able to formally verify, thanks to agents, very complicated code, things that we weren't able to formally verify before, because there is other automated techniques for proving, but they are bounded in the sense that we cannot verify complicated code to make it easy. I can go deeper after.
Okay.
But yeah.
So it's the proof part of it. There's the modelization, there's the writing the rules, and then there's the creating the proof. And the proof part is a whole bunch of code, but thanks to AI, the whole bunch of code part is easy. And as long as you have a good eval loop that's very clear, like how you evaluate the thing, that's like giving it the observability of whether it's correct or not. That's like the part that AI does really well. Am I saying that correctly?
Yes, and I will emphasize on the fact that it helps also a lot on modelization and on like writing the rules, as much as it helps to write JavaScript or to do the meeting we're on right now. But
the slop, you were in it.
It was something that just...
No, sorry, it only works on mine. I gotta get it for everybody.
For the proof, it was something that was completely not possible before. Because, for example, so to give you a little story, I'm French, and there is a metro in Paris that brings you from the airport to Paris. And the software, it's an automatic metro, there is no driver. And the software that is in this subway, so metro subway, is formally verified. Because the French state that did that has access to infinite PhDs for basically free. But in real salaries, it would be like, I don't know, it's a very easy code, but 2-3 million a year. So this is just not economically viable for most of startups. Even for Ethereum, that had a huge capitalization, most of the protocol is not formally verified, even now. Imagine for like classic startups. So basically only the US military and some like European militaries do it, and AWS in the economical world before AI. We believe that after AI, we're starting with smart contracts, but everything will be formally verified as long as it has some kind of importance in terms of correctness.
Okay, so the doing of the formal verification requires like hella work to be done by very smart people, and that makes it very expensive and economically unviable. But now with AI, it's much more viable. And so hold on, the French metro, the Paris metro is formally verified. Like it knows like these two cars will never run into each other mathematically or something.
Yeah. The idea is that so if you go to like the south of Paris, there is an airport called Orly, and this airport has like, I would say, very small subway, but it's just the subway to connect from Paris to the airport. So it's just this subway that is formally verified, and it is formally verified. And there's bunch of small part of softwares in airplanes, in trains that are also formally verified because the regulation needs it.
You need to know
like,
for sure
words.
you're not going to crash. Yeah. And with lots of money, smart contracts, this is another thing that formal verification is very important with. It's just super hard and super expensive to do. But what you're saying is now that there's AI, it's actually not as hard anymore or expensive.
Yeah, it's still hard, but it's just way less expensive.
Economically
you still need
viable.
probably some smart people running it, but we can do way more of it.
Dope. Okay, so let's say I am a smart contract engineer, but I don't know anything about formal verification. How do I go about getting my smart contract formally verified?
Yeah, so there's like different ways of doing so. After you've done all the classical tests like fuzzing, invariant testing using Foundry or some similar frameworks, formal verification is a step on top of that because it does not just test some random combination on your functions. It tests all possibilities,
everything,
and prove like all possibilities are correct based on your specs, so on the rules it has to follow. So that's formal verification. Then you have different way of doing formal verification. You have like, you can use the tooling yourself. So Verity is open source, is granted by the Ethereum Foundation. You can use it and modelize your contract, write the specs your contract have to follow, and then launch an LLM to prove that the implementation of your
that whole process. Can I just give that to Claude? Can I give this Verity repo to Claude and say, we need to modelize, write the rules, all that?
Yeah.
Will it be able to kind of figure that out? Are there like skill files within this that sort of kick off the AI?
It's not even needed, in my opinion, it's not even needed a skill file. Like you just give it the documentation, he's gonna understand everything of it, and he's gonna be able to like make a good model, make some good specs, and verify it. Depending on your budget of inference. If you have a $20 cloud, it might gonna be hard. $200 depending on your contract also, but it's like pretty expensive, especially on the verification side. But with that being said, you can do that, and for probably easy contracts, it makes a lot of sense to do that, in my opinion. But yeah.
How long does it take? Let's say easy contract.
Well,
a staking contract with deposit and withdraw and a few other functions.
It depends on. I think cybersecurity is a market, right? It's like the attacker also has this model. So
yes,
you don't want to like completely vibe code your thing and say, okay, I'm now a superhuman, because yes, you are a superhuman, but as it's the market, the attacker is also a superhuman, so you guys are both human anymore. Like it's like,
and he has an infinite amount of time to attack it. You have to get it right on the first try, and he has an infinite amount of time.
Right, so I wouldn't say, oh, you can, because it depends on the quality of what you're outputting, but you can say, oh, you can do it in like one prompt in 15 minutes, but you can also not review it. But it will really depend on how deep you want to go and what's your experience on it. Because if it's the first time, you don't know what to review, what to look at, you have to like understand what's the difference between the monetization. And overall, I would say the bottleneck is you being able to know what is quality. You being able to take ownership of what the model did. And that will be the bottleneck from now on, probably for eternity. In the sense that these models are capable of everything. The question is, are you backing their work? Because at the end, it's not like the fault of the model if your protocol is getting hacked, it's your fault. It's yours. You're going to get the consequence of that, right? So it's like, it really depends on how good you are at reviewing and like taking this ownership of everything. But that's why I cannot like tell you an answer. It's like you can one-shot it in 10 minutes. You can pass 2 days on it. It will depend on your skill, and it will depend on the stakes. We believe.
So the longer you spend, the better. I was thinking like formal verification was kind of, like you said, binary. Like it is now formally verified or not. But there's some like you spend more time on it, it gets more formally verified or something.
Yeah. So
you tell me.
It depends on. So formally verified is binary, but I can choose what I formally verify, and I can choose what are the assumptions. So I can even I could say, oh, so we formally verified. I don't know, the Aave protocol, for example. Yes, but we took in assumption all of the code that we can say, can I share my screen? Maybe
yes,
you can.
Please do. It's it's right over here. That screen right there. Yep. And we can move this. I can minimize my screen for now, and we can bring it up later. Yep, right there. I don't know. Permissions might be weird. It took a bit to get your video. No good. Tell me what to share. I'll share it for you. What do you want to share? Drop it. If you just drop the URL in this chat right here, then I'll grab the URL and put it into mine.
I've sent it.
Got it.
So this is a work we've done with Lido, where basically we formally verify one invariant of their protocol. So one rule in the Lido Vault protocol. So it's not the Lido staking contract, but it's the Vault protocol they did. So we explain, okay, how we modeled, why this matters, etc. But if you go down, you have some hypotheses that this proof relies on. This means while we are like saying, oh, Lido is formally verified, there is a bunch of hypotheses
like external
for this to be true. I'll give you a very easy example. So for DeFi guys, you could say, oh, we cannot have bad debt because we have liquidation. So someone is going to come if there is an opportunity and liquidate people. Well, that depends also on the Oracle price. If the Oracle price is not good, then you have a bad debt, you have a problem, right? So the assumption is
the Oracle price could go to zero, and then everything's like there's nothing you can do about it. Yes, even though you have like the correct
for the system to work is
go ahead.
Yeah, the assumption for the system to work is the Oracle price is good. So in a formal verification, you will always take assumptions on your model. You will say, oh, I trust this, I trust that, I trust this, especially in smart contracts. Sometimes it's built on top of other smart contracts. So do you formally verify these other smart contracts too? So you do not take them as an assumption, or do you take them as an assumption as they work correctly? Up to you. But this is what I mean by that. So you have two main things that you have to care about when you do formal verification is, well, how good are your specs? Because sometimes you can forget a rule to formally verify, and you can say, oh, we forget this rule. Well, the attacker hacked it. It happened like a few times. Or we took this code, for example, or this part of the system as assumption, and the attacker, well, used that part. So again, an example, Resolve. So Resolve was, the stablecoin. So it was hacked for a lot of money, and I lost a bunch of money on the hack too. And basically, it was a private key hack. So we could have formally verified the whole contract and say, oh, everything works correctly. We will take as assumption that the private key is not compromised.
Yeah.
If there is an upgrade path, we will take as assumption that the person that owns the private key for the upgrade will not upgrade maliciously. So we will take assumptions. So it's not like formally verified yes or no. It's also like, okay, under the specs, the formal model, and the assumptions. So it's like, it's always a bit more complicated, of course, but it is a solution for the mythos, apocalypse, or whatever. Not this ultimate solution. It's not like that easy. I would like it to be, but it is one of the solutions, and we believe it is probably the best solution we have for correctness of smart contracts and code in general.
Great. So I have this service $1 audit, and it makes me think that someone should be doing formal verification as a service, like as like an X402, like leaning into AI and leaning into the fact that you could just give a smart contract and this library to an agent, and the agent could at least formally verify the smart contract with some assumptions around it pretty quickly. Is anybody doing that yet? Like, is there any like formal verification as a service to be part of your CI/CD pipeline?
You mean in some kind of like an agent?
Yeah.
So there is some company doing that. It's not $1. If you want to do a $1 version, I would love to help you build the skill and test it out for you.
Hell yeah.
Because I saw your $1 audit, and I thought it was really cool as a concept.
Chill.
To me, these things is like probably I would say the future of not formal verification as a service, but it should be part of the process of building a protocol or building any kind of software, because you have access to these AIs that are basically PhDs in data center for 50 cents an hour. So you should use them as much as possible. Then, as said before, I think the bottleneck is not like the intelligence anymore, but it's the ownership and the capability to say, yes, this is good. And this, you can talk to like
This is
firms,
very hard.
audit firms and like people that will do so for you. And this will probably stay, in my opinion. And yeah, I believe basically in the market, it will be like either that, like agent as a service, $1, $10, I don't know exactly what will be the price, or premium service where people say, put a stamp and say, okay, we
Like a
and our
human.
enormous brain, we
Yes.
take ownership on that, and if it bugs, it's awful, basically.
Yep. Okay, cool. That makes a lot of sense. And yeah, so okay, so we've got a language that you've built for formal verification, and you've built it with AI for AI, and we could see some kind of like AI agent system running this system and doing formal verification for people. But what I really want to get into is that how you built it part. Like, what is your stack? Are you a Codex guy or a Claude guy? How do you go about building your own language for formal verification?
Well, good question. So building a vibe coding in math is really, I would say, easier than vibe coding in normal languages and normal product as the product we're on right now. Just because the feedback loop is really easy in terms of what's good, what's bad. Because it compiles or it doesn't compile, it's formally verified or not, and it's like way easier for the agent to add feedback loop and to advance autonomously than it is when you're coding a front end or you're coding an app or whatever. Even though it's possible. Yeah. So we've worked a lot with agents, and we have like a few steps. Mainly the first step will be like getting really, really clear on what you want to do before, and pass way more time at trying to understand what you want to do, the taste of your project, what are the specs and everything. And then giving the tools to the agent to verify autonomously his work and work when you're not here. So this means for my verification, it's very easy. It means, just give him Lean or a compiler, and he will be able to verify whether it's formally verified or not. But for a front end, it will be give him a Chrome, give him a way to understand what's good front end. So a way to understand the screenshots, a way to like compare it to a design, something like that. We even did some video games. So in that case, we were like, okay, we need to modify the video game so the agent can use it. But working on this feedback loop is very important. And then it's easy. Like once you've done that, you can launch agent and they can iterate, and then you just have to wait for the feedback of your user so you can like relaunch agent, have new features and have new ideas. But once you did, I would say, the vision and you have all the tools enabled to have these feedback loops, you have your duty is now only to have IDs and to be in the flow as the father of vibe code.
It's idea guy summer. Yep.
Yeah, it's ID guy summer. You can have no technical ability whatsoever, and it can work. Well, when you're building a smart contract language, no technical ability whatsoever, it's not good, because like having good product ID is technical ability. But if you're doing a front end, if you're doing a classic accounting product or whatever, you don't care. But now in terms of model, we're using all models possible. We have a router inside our company. So basically what we're doing is that we use all subscriptions. So Codex, Claude, we have Codex, Claude, 2 or 3 Chinese. So there is like GLM and Kimi we have. And we tested Grok also. So we have like all the subscription, at least low tier. And for Anthropic and Codex, we have like several Codex highest tier, several Anthropic highest tier. just because it's just like very, very cheap comparing to a business subscription. So we just have like several accounts, B2C accounts that we run in parallel, and we add all that into an API that we can call. And in this API, we can say, oh, we want frontier models. And when we finish one codex, it passes to the other codex automatically, or it passes to the other Fable 5 or the other Opus 5, the frontier. And then we have like lower, which is basically normal work, front end, or things that do not need a lot of thinking in terms of implementation. And this we pass it to Chinese models or Terra or Luna, this kind of models. But in terms of managing our difference, this is what we do.
So I think what you're talking about is like actually running the formal verification and doing like some of these audits, like you did for Safe and Lido and Morpho, I think. But I'm zooming in on like the build process itself. Like when you sat down to build the language itself, you were using all these different subscriptions and all these different models in this way? Or is this like thing you've described for when you go formally verify someone else's code?
It's both, because everything relies on LLM. We're formally verifying with LLMs, and we are building the protocol, the compiler with LLMs also. So all of this infrastructure is basically inference management for this to cost like less, because in terms of API cost, we have like 25K a month. It's stupidly high. But in subscription, it's like 1 or 2K a month, something like that. So we've built all of this infrastructure, and as said, I try to like be low level, I would say, because this is what we use for building whatever. It's like, first, understand what you want. Second, build this feedback loop. Third, improve it. And then do that. And if you think on these three steps, whatever you build, you're going to figure it out. Because this is basically the 3 steps of the agent. And the hardest step is giving the feedback loop and getting the idea of what even to build. What is good, what is taste. And yeah.
I think that's a theme that I've had talking to a lot of people on Slop.Computer. Yes, like the idea and the taste is sort of like the human thing. And you bring that to the table, and then you have to have a very good plan or a very good spec. And then you have to have very good observability or evaluation. And that's what you're talking about. And then I think the third thing you're talking about here is something we haven't talked about as much, but it's improvement on that. Once you have the spec, once you have the observability, you kind of have that. It's already in a loop, but you want it to be sort of improving itself as you go.
Yeah, that's difficult. I've not figured it out like completely, to be honest. I've used like some auto improvement memory, auto improvement of skills. It works well for personal use cases, but each time when I do it on professional, it always does some things I didn't think about. And add a lot of fluff in my code base. So in general, I just like copy paste the whole transcript and the thinking trace, and I will say to another agent, what do you think we can improve there on the skill we used, or the memory, or the cloud.md, or all of these agent files, and then I'll choose what he will add and remove manually. But doing that in an automatic way, I'm still like struggling, but probably will be there.
And you're using frontier models, both Codex and Claude. You're using multiple subscriptions across both, which is awesome. You kind of have them argue a little bit. And then you said you go to the Chinese models for like secondary things. Is there some kind of like triage system you have, or do you just like pick out like these tasks go to the Chinese models, these tasks go to Codex, these go to Claude? Or is it doing that like dynamically, sort of like you prompt it and say, this is my intent, and it knows to go to Claude, Codex, or the Chinese models?
I found like trying to filter on the intent is pretty complicated, and some companies are doing that like for a living. What we do is just like routing when we have no money anymore on the subscription, like no credits.
We're out of the good ones, so now let's just go to the Chinese. But the Chinese models are very good, though, right? Like they're
no, but like it's really recent. It's like 2 weeks or 3 weeks. Kimi is like Opus 4.8 8, 9, I don't know, level.
Wow. Okay.
And
then DeepSeek
yeah.
just came out like a couple days ago.
And like there's one that came out 2 days ago, but it's like they are very good. But if we're not bottlenecked by the best ones, let's use the best ones.
Let's use them. Okay.
And it's not that expensive comparing to on subscription, B2C subscription. If we were like a business API, which we should, I hope you don't have too much views, because otherwise I'm gonna get kicked out of ChatGPT.
Don't worry, we don't have very many views.
Yeah.
This is a very niche podcast.
If I pay API price, honestly, yes, I'll use like DeepSeek and Chinese model more. But like, why would I pay API price? I work on open source software, so they're telling, like, they're getting my data either way. So I prefer to like not use API price. And
one reason might be because Fable won't let you, right? This is another thing that you've tweeted about, I think, is like, yes, Fable blocks you a lot. What do you do? Like when you're trying to do formal verification stuff, it's very security adjacent. Like, how do you get around the Fable safeguards, or do you?
Yeah, so Fable doesn't block formal verification because formal verification is not finding bugs, it's proving the absence of it. So that's very cool. And I tweeted about it like in a funny way, saying we are the only guys not blocked by Fable, basically, when we're doing stuff. But Fable is like too expensive to run proofs on itself. We prefer to use like smaller models. But with that being said, it's true, we're banned every week by one of these accounts. Like every week we're banned, but we just like ask again, hey guys, we are working in formal verification, we have an audit firm, and they deban us because it's automatic, they don't really check. But Fable is completely unusable for anything outside of formal verification, to be honest. So I don't use it personally. I find it too expensive, taking all of the credits, and like completely micromanaging me, saying, "Oh, you shouldn't do like this. Yes, I asked you to do like this. Please do like this."
I'm the boss. Yeah.
do that on legal, on cybersecurity, on anything that is like he finds shady in a way. So yeah, I'm not using Anthropic so much right now. Fable is still probably the best model, but I'm not using
safeguards.
Too many safeguards. It also eats your token. Probably it's like 50% of the price you pay is the safeguards. So it's really it's really frustrating to work with Fable. When GPT accept to do most of the things, like, and when they have a doubt, they ban you. You just appeal 24 hours after, they say, sorry, we banned you for nothing. They did like 3 times in the last month, but they take 2 days to unban me, and it permits me to take my weekends.
At least you get unbanned, man. I feel like there are some places you get banned from, and there's just like no one can help you, and it's just like, damn. Okay, yeah, so let's like talk about. Well, Twitter is one. Like I had the Twitter account for this podcast. Someone registered it, and then I registered another one, and mine got marked as spam, and theirs didn't. And then I like reported it as spam, and they didn't do anything about it. But whatever. I like decentralized systems more than centralized systems, but I don't want to go too far into it. Let's get into these actual like formal verification audits that you run this system on. I think I mentioned Lido and Safe and Morpho earlier, but I only have that for my research. I don't know if that's true. Are those your kind of like big 3 that you've done, or is my research bot?
We've done a lot of research. So we're working with the Ethereum Foundation on Verity. So they granted Verity, and apart from Verity, we are using Verity on a lot of production protocols, and we try to talk to as much team as possible to try to use Verity, talk about Verity with them. And we're doing one invariant, so one rule. We're formally verifying for them in general as like a first test. And we did that with like 15 to 20 protocols now, and we do maybe 1 to 2 a week. And then we have like clients that, on a paid basis that we work with, and some of them are in the list, but yeah.
Let's talk about that, like specifically like a new client. Let's say a 4th client comes in out of these, a 4th big client. You have lots of little clients, but like a big client comes in like the Gnosis Safe. I would not want to have it be my job to have to audit the Gnosis safe. Like those contracts are gnarly and huge. What is the process there when the Gnosis safe or someone similar comes into you and they say, we want to get formally verified, and you have this really cool, audit skill, I don't know what it's called, audit system language, you have this protocol, you have all this agent stack, like all this AI stack, what happens? There has to be a lot of human touch on top of it, but then you're like really kind of your superpower is hopefully like the agents underneath.
Yeah. So first and foremost, I'm not the one doing the audits. It's my co-founder Thomas that is doing the audits, and he's like building most of Verity. I'm more like applying Verity with the protocols. So I'm using Verity as a user. He's building the compiler himself. But with that being said, the process for formally verifying a protocol, the goal for us is to prove the absence of bugs. In order to prove the absence of bugs, we have to have no bugs. So we have to make a normal audit before and get rid of all the bugs.
Okay.
So that's the first step. The first step is looking at your code, sending a bunch of agents, trying to really understand the whole system, the architecture around it, what are the edge cases, and then find all the bugs and do a classic audit. Once we do that, we use formal verification to now, here are all the bugs. We're going to try to make sure there is no bugs anymore. And that's the big difference with a normal audit is the guarantee you have. Because with a normal audit, it's basically, there's the guy looking at your code. He say there is bug or there is no bug. Then it's finished, but you do not have any guarantee that there is no bug anymore. And formal verification blocks that and say, well, under these specs and the assumption, you have no bugs anymore. That's a bit the goal. So that comes as a second step. We come and do the 3 steps that I talked to you before, which is first, we modelize the contract in a mathematical way. Second, we write all the rules the contract must follow under a certain amount of assumption and hypothesis around the rest of the world of the contract. So the Oracle price, the upgrade path, the private key, this kind of stuff, depending on the contract. And then we prove it. We can use LLMs. We can also use automated techniques if it's relevant. But yeah, that's a bit the process. And in general, it's like a lot of work before to understand fully the protocol, write all the rules, write all the assumptions to formally verify at the end. Most of the work is actually understanding what we have to formally verify, write the rules, understand what are the assumptions, how strong are each one of these assumptions. Okay, we have to trust this guy. Is this guy like, is it a big problem? Yes or no? It's really like a work like that. And over all of the process, we use agent at all level to help us in the process.
Heck yeah. Okay, that makes sense. So it's like the formal verification kind of happens after the audit, and the audit is the important part. And you have to audit it to make sure there's no bugs, and then you formally prove that there are no bugs. Okay, so let's look at some of those folks that you already had through Morpho, Safe, Lido, and others. What's maybe like the scariest or the biggest thing you found? Maybe you can't even say. Like, can you even disclose that you found some critical thing?
No, but no, because we are like pretty early, and we started this. I said it wasn't possible before, so we started this pretty early, so 6-7 months ago. And the first engagement we have are still ongoing and not public yet. So
got it. That makes sense. What about this? There's a tweet from you, basically like peers going full corporate. Why not you? Like, what is it about not going corporate? I don't know. Just like pull that thread a little bit and talk about your own preference.
Yeah, I can. Basically, yesterday was my birthday, and I met a guy.
Happy birthday!
Thank you. And I met a guy that is a childhood friend of mine, and he's working in McKinsey. So McKinsey, famous consulting company, and the perspective of salary for him and possibilities, especially if he goes to the US, which he could, are very high. I was impressed by what's possible. And I was like, for a smart guy like him, it makes a lot of sense to actually continue that, financially at least, to actually continue that and max start this way, because in terms of expected value, that's where he can earn the most money, probably. Comparing to, and I made the joke, comparing to like someone that is starting entrepreneurship and doing a $20 a month micro SaaS. I've done that for like the last 7 years. So I'm basically unemployable anymore. And that's why I don't even take it as a possibility. I'm completely unemployable. I worked as a software engineer for like 6 months, and I left because I couldn't. So for me, it's like, in an expected value way, I would say, like, comparing to the people I was in engineering school with, it's probably better to choose the corporate job, especially in the US.
Yeah, I don't know if I got exactly like why you wouldn't then. Like maybe you said that. I don't know. I want to pull that a little bit more.
That was the question, I didn't. It's just like, me, when I was in school, so growing up in France, the possibility wasn't really on the table. So yeah, the salaries in France are so low comparing to what I understood was possible yesterday with McKinsey or other AI firms. I was like, there's no way I cannot make, I don't know, 40K a year as an entrepreneur. I was like, that's pretty cool. I can make that as an entrepreneur. That will be the salary I would have, maybe 50 or 60 euros, so maybe 70K, okay, in dollar. There's no way I cannot make that as an entrepreneur if I give myself 2 years. But when I'm looking at the possibility for McKinsey and corporate, I was, maybe 250, I don't know, 300 as a junior, I was like, okay, that's completely another game as an entrepreneur. I know because I've done that, and that's completely another thing. It's way harder. You have to manage people. You have to grow the business. It's way harder. And I was just mentioning in this tweet that expected value is actually better, something that I didn't think it was 7 or 8 years ago when I started entrepreneurship.
Okay, so it's more just like your own expected value of how this works and entrepreneurship, and even like higher salaries in America.
Value. It's not having fun. I have way more fun here on the Ethereum ecosystem for the like 5-6 years than probably in McKinsey. But it's just purely money. I'm happy that I didn't get the possibility to be,
because you would have taken it
in New York or SS, because I wouldn't do that. I would be 100% in the corporate job because I would have this opportunity as an engineer, and at 19, 18, I wouldn't be able to refuse 200K or 150K job.
That makes more sense. And like there's something cool about just being cypherpunk too, and not having to go to like corporate corpo slop meetings every day. Like there's something more fun about this.
That's why I say now I'm completely unemployable. Like I've tested that, right. So now it's like it's finished. Unemployable. You can give me lots, I won't do it. But at the time, at 19, probably I would have done it.
So I wanted to even touch on Starknet ID. I saw that a little bit in your research history. You want to talk about Starknet ID? I think it was something that you built and launched to 300,000 users or something like that. Is that right?
Yeah.
Is there what is it? What does it do? Like, how did you build it? Was this something that you still were building with your fingers, or was that actually like AI was able to build it?
It was the first year when ChatGPT came out, but ChatGPT was good for like scripts, but not really for like building apps and stuff. So it was copy pasting a bit, but it was really bad ChatGPT at the time. So basically, the story on Starknet was that I was a user and I would say content creator-ish on crypto for like 2-3 years. And I saw this opportunity that Starknet was really, really early, and some friend of mine told me, oh, it's a really good L to build on. And I've done some research, and at the time, it was the best tech. It's probably still now, to be honest. But I've basically spent 3 years of my life working on Starknet full time, and we've built a lot of things on Starknet. So we build bridges, we build games, we build a lot of things. And one of the main thing is Starknet ID. That was, I would say, a version of ENS for Starknet to make it easy. So it was basically a naming service on Starknet. And we've worked with like a lot of, it's apparently
weird.
The CSS is not charging.
The CSS didn't load. Yeah.
So it is directly on Starknet ID. I'll debug live. Yeah. Yeah. So we're not working on this anymore for the obvious reasons that we know that NFT actually do not work and Starknet actually didn't work as well as intended. But the website should be way better than that.
It'll probably load later.
You can go to app.starknet.id. You'll see the actual website. It's still live. We're trying to like make it, I would say, unstoppable. So we still have a lot of users and people that still have the domains. We're trying to make it unstoppable, but just the size of the community on Starknet is not as big as intended. And overall, the product market fit on NFTs and identity is not as big as intended. And we've seen it today with PoApp, for example.
Totally. Okay, let's see. Usually I have Claude like come up with some questions here. Let me send him to come up with a question a little bit. Let's see what he comes up with. So basically that my AI agent like reads the skill files, understands like you and your history, and then he'll ask you a question. I don't even know if I did it. Mic check.
Hey, Ben, you mentioned you've been talking to math PhDs lately, and the mood is basically doomerism. You're excited about formal verification getting commoditized. They're gloomy about it. What do they see coming that you think they're missing?
That's a good one. There's a lot of people that are like gloomy about AI, right? Like what are math PhDs? Yeah, go ahead. Sorry, I should let you answer.
Yeah, continue.
What? So like, we see a lot of even like Gen Alpha kids like hating on AI. It sounds like math PhDs are hating on AI. It seems like AI is like very powerful, and for me as a sloperator, an idea guy is like I can do so much with it. Why are math PhDs negging on AI? It seems like it's useful for them too. Is it just doomerism? Like they think the world's gonna end? Like singularity?
It's not doomerism. It's honestly, I understand. I'm not a PhD myself. I'm doing applied engineering, so I'm very happy that this exists. But a math PhD, he bet his whole career and 8 years of his life minimum.
That's true.
To being the smartest guy in the room when it comes to math.
Yeah.
Now everyone going on a website called chatgpt.com can talk to a guy smarter than him. And everything he was able to do, now a machine is able to do it for 50 cents an hour. So we can understand that this guy is basically a bit, I would say, frustrated, at least, by the state of how his job got commoditized. And especially for people that are not excited by I would say, commercial use cases. I'm an entrepreneur. I'm excited by commercial use cases of formal verification, the fact that we will be able to formally verify the world and secure software in general. Math PhDs in general and the researcher we see on Twitter, they are working to prove theorems that do not have, especially in general, a direct application, and they are funded by university and governments. So they are very far from the commercial the commercial use cases. So they are not really excited by the commercial things. They were excited by the idea of proving theorem manually and thinking about it. And now that really like an LLM in a loop can do all of what they did better, faster, cheaper, it's really hard for them. And I can understand.
No, that's a good take. Okay, so like math PhDs have, like you said, like spent their whole life trying to be the biggest brain in the room and use their brain to do these things that like computers can do or that LLMs can do, and the new kind of computer can do better than them. So they kind of like made the wrong bet in terms of like what they get really good at. And so now they hate it because it's kind of taking their job. That's okay. That's different than like I would say my kids are hating AI because of just like slop, and everyone's using AI to send, giant messages, and it's just like gross. But I think the slop will go away, and eventually the models, like a sloppy sentence or a large sentence, will be the sign of like a human freaking out, and like AI will just get better and better and more precise eventually.
To me, if someone sends you slop, it's not the fault of the AI, it's the fault of someone.
Yes.
Because the AI is capable of not doing slop. It's just the person that is using the AI is not capable of understanding this is slop.
Yes.
And that's again, we come back to what I said before, is that now the bottleneck is taking responsibility on what you're doing and having the agency to do it. And especially on the audit side, the idea is that there is someone with a big brain and a lot of AIs that said, yes, this is good, and that gives you the confidence to continue to production, basically. But yeah.
Great. The human touch is still very important, even in these like highly mathematic or formal verification.
I'm not even sure. To me, it's not the human touch. It's just that in an organization, someone has to be responsible and someone has to understand.
Okay.
And even if this someone doesn't do anything like technically, but just understand what's happening and say, yes, this is good, he's taking the ownership in the organization. And if something fucks up, someone's going to come to him and say, what the fuck?
Yes, it was you. The buck stops at you. Yeah. I think someone said this, maybe it was Carpathy. I can't remember who said it, but it was basically like you can outsource your thinking, but you can't outsource your understanding. And what you're saying is like someone needs to understand this at the end, and it has to be like the buck stops at a human. Right? It's not like human touch, it's human understanding over the whole system. Okay. Yeah. Cool. Awesome. All right, that's it. I'm going to have Claude give us an outro. He's basically just going to give us a summary of how it went and say goodbye, and I'll get some music going. Thank you so much. This has been cool,
homies. Man. Big thanks to Ben, Ben, the man who vibe coded an entire language, Verity, formal verification in Lean 4, already proving invariants on 100 billion in TVL with Morpho, Lido, and Safe. Formal verification used to be for the Paris Metro and the military. Now it's PhDs in a data center for 50 cents an hour. Unemployable at 19. Cypherpunk over McKinsey. Go follow Ben. Go check out Verity. Stay sloppy. See you on the next one.
Stay sloppy. All right. Thank you, Ben. Thank you for being here. Have a good one. Thank you for being here. See you. I wish I need to get more thoughts for everyone. All right. Keep building. This is awesome stuff.
You too. That was awesome. Thanks.